Hi, this is Alex,
And Arjun.
and this is our percent purity of metal using gas laws lab. So what we did for this lab is that we wanted to find the amount of gas produced at the product of impure zinc and HCl. So what we first did is that we filled a barometer with water and then connected that to a flask with a rubber tube. In that flask, we would then put the zinc and the HCl, but first what you do is that you put the barometer upside down into a 500 milliliter beaker. Um, After you measure out the amount of impure zinc, you have to do these calculations, as you can see on the board, to find how much HCl you mix with the impure zinc. So you add the zinc and the HCl into the flask, and then you top it up, and then you watch the bubbles or the gas product go into the barometer, and the water volume then goes down because of the extra gas in.
Alright, what you see on the board right here, is the balance equation we wrote out. So it's 2 HCl, which is aqueous, plus zinc solid equal, well, to make H2 gas plus zinc Cl2 aqueous. So, right here we have all our measurements. We have, for the barometer, it was upside down, so it started at a lower volume. So it started at 11.5 milliliters and ended up at 46.8. And the temperature was 20.5 Celsius. That was the temperature of the water in the beaker. And the grams of the impure zinc, which we measured out, was 0.565 grams. And right here we have that calculations. We're just figuring out how many moles of zinc we have. So we have 0.00864 moles of zinc. And since it's a 2-to-1 ratio between the zinc and the HCl, we multiplied that by 2 to find the moles of the HCl, 0.0172 moles of HCl. And Mr. Angelo, or our teacher, told us that the HCl had a 3.00 molarity. So to find molarity, it's moles over liters. So we put 3 equals 0.0172, which is the number of moles, over X, which would represent the number of liters. And we got 5.7 milliliters of HCl, which was 0.0057 liters of HCl. Alright, and next we have here, it's the same equation, and we have our gas laws right here, PV equals nRT, and here we found the volume by subtracting the end volume from the initial, and we got 38.4 milliliters of H2 gas, and then we found the pressure of the H2 gas using our water vapor to our temperature to water vapor chart that you gave us on our homework assessment, and we figured out that the pressure was 0.975 atm. And then we have the equation just rewritten to find the number of moles. So we found N equals PV over RT, and N represents the number of moles, and then we plugged in everything. So that's 0.0384 liters times 0.97 atm over 0.0821, which is our R, and 293.5 Kelvin. We found out the number of moles of H2 gas was 0.00155 moles of H2 gas. Alright, so now we have the moles of H2 gas. So we have 0.00155 moles of H2 gas, and we converted that to the amount of moles of zinc there would be. So we have 0.00155 moles of zinc, since there was a 1-to-1 ratio, and then we found out how many grams of zinc that would be. So we found out it would be 0.101 grams of zinc, and that would be our theoretical. So that's our theoretical yield, and since we did that, it's theoretical over actual yield to find the percent purity. So it was 0.101 grams of zinc over 1.65 grams of zinc, which was our actual, to find 6.14% purity. Multiplied by 100 to find 6.14% purity. And one thing that you could do wrong in this lab was, which we did at first, was we had too much zinc, so therefore we put in too much HCl, and the reaction created so much H2 gas that there was no water to calculate the theoretical yield. And did we miss anything?
No.
All right. Thank you.